Hello, my friends, and welcome to the Matrix. Well, I guess we're in the real world, so we're going to learn about matrices anyway. So, what matrices are is they are ways to organize data, and they are organized by dimensions. Now, dimensions you can think of, or you probably know of, as like a box, and it's, got a height, a width, and a length. Well, matrices are organized like this. They have rows and they have columns. I don't need that. NS. Okay, rows go across, columns go up and down. Think of Romans. Romans used columns to build their buildings. They had nice big thick columns, and it held up these things like this, and they had that like that. Anyway, so say we have a matrix and it looks like this. Okay, it has 3 rows and it has 2 columns. So you would describe this matrix as a 3 by 2 matrix. Okay? Just like in the coordinate plane, x comes first and then y, x runs horizontally and y runs vertically. Well, y in a sense is your column, and your x is your row. So 3 rows, 2 columns, 3 by 2 matrix. So this matrix would be a 2 by 3 column, 2 rows and 3 columns. So that is how you describe matrices. Now, matrices, as I said, are used to organize data. Now, in order to organize that data, you need to be able to find pieces of it quickly and efficiently. So, how they do this, say we're given a matrix, and it is matrix A. And it's organized, let's see, negative 18, 6, 38, okay. So first, this is a 2 by 3 matrix, and say I needed to call on, I don't know, 22. Well, this is row 2, 3rd column. So this would be A23, little a, because this is matrix A. So A23 equals 22. Well, what about A11? First row, first column, so that would be negative 18. And again, you can think of this as like how a point on the XY graph. Row, row, column, column. So that is how the points of a matrix are organized. Now, matrices can also be viewed as equivalent or non-equivalent. Now, in order to be equivalent, a matrix must have the same dimensions. That's the first qualifier. So if a matrix one matrix, let's say matrix B, is a 2 by 2, well, it can never be equivalent to matrix A, as we said above, which is a 2 by 3. The only way matrix A could ever be equal to, let's make up a matrix C, and let's give it the same dimensions. They have the same dimensions. They're both a 2 by 3. And they also have the same corresponding points. Negative 18, negative 18, 6, 6, 38, 38, so on and so forth. So A11 would be equal to C11. That is how you can consider if a matrix is equivalent. And that is your first video tutorial on matrices. Welcome to the real world, Neo.